Hmm.
Invece tutti le
Hey, hello everyone. Am I audible? Hello, am I audible to everyone? Okay, fine. So let's start. Okay, everyone. So in last class, so basically we have been talking about, I can say, a NumPy. So we have discussed Pandas, we have discussed NumPy. So in today's class, so we are going to talk about a visualization technique basically. So there are lots and lots of different libraries which is available inside Python, and which will help you out to like get insights in from the data set. So which will help you out to visualize a data set at any point of a time. So let's try to understand it. Let's try to see that how we'll be able to use different kind of graphs and how we'll be able to visualize the data set at any point of a time. So fine. So first of all, so we are going to see a multiple libraries, I can say. So we are going to see some of the libraries we are going to see some of the libraries like a matplotlib. We are going to see some of the libraries, I can say, like a plotly and couplings, and we are going to see some of the libraries like a cborn. So am I audible to everyone? So someone is saying that voice is not audible. Hello, am I audible? Okay, fine then. So yeah, and lad. Who is this lad? Again and again, he's trying to ping that NumPy is not completed many times. I have already seen that. So NumPy is not completed because what I was assuming is like Chris has already completed this NumPy things. Yeah. So it's like in a weekend, so it's already been done, and we have already uploaded the recordings as well. Yeah. So many people are saying completed. Okay, fine then. So we'll continue. So here, so we are going to talk about visualization technique, basically different kind of libraries we are going to discuss. We are going to talk about. So basically, there are so many libraries which is available. Matplotlib, cborn, couplings, plotly, bokeh. I can say many other libraries are also available by which you will be able to do all those plottings and visualizations. Apart from that, so lots of dashboarding tools are also available, which is going to help you out like MSBI or I guess say Tableau or Japlin or ClickView, ClickSense and all those things. So yeah, so we are not going to talk about dashboards as of now. So we are just going to talk about like a Python packages, which is going to help you out to visualize a data at any point of a time. And out of that, so you will be able to get some of the insights of the data set. So the whole idea behind this visualization of the data within like a Python library is to understand our data into a better way, into a visualization way, so that whenever you are going to make a decision, so you will be in a better position to make a decision at any point of a time. So fine, let's try to do that. Let's try to understand it. So how we are going to implement, how we are going to achieve each and every things at any point of a time. So first of all, I'm going to start with the libraries called as matplotlib, and then I will talk about plotly and couplings, and then I'll talk about a different kind of libraries. So here, first of all, we are going to see that how we'll be able to use this matplotlib libraries, and with the help of matplotlib libraries, so how I will be able to plot a different kind of a graph. So here, as you can see, so I'm trying to import different libraries like a NumPy, Pandas, cborn, and matplotlib. I'm trying to import over here. Now, NumPy we have already discussed inside your class. Pandas, yes, we have discussed that as well. Cborn and matplotlib we have not discussed, so we are going to talk about that for sure. So here, so I'm just trying to import each and every library, and here I'm trying to use percentile of matplotlib inline. Now, the meaning of percentile of matplotlib inline is so basically whenever you will try to plot a graph inside your notebook. So at that point of a time, you are supposed to add these things. If you are using older version of Python libraries, if you are using a newer version of Python libraries, in that case, you are not supposed to write this line. So even without writing this line, Python library will be able to print your graph inside a notebook. If I'm talking about some other IDs, so in that case, it's completely fine. So even if you are not using this line, so you will be able to get your graph basically. So fine, I'm going to import all of those libraries again. So here what we are trying to do is, so we are trying to create a data frame. So as you can see, so I'm using a random function. So in NumPy classes, we must have discussed these things, that what is a random function, and inside this random function, so I'm trying to give like 1,000. So if I'm going to give 1,000, so basically it is going to generate 1,000 numbers for me. And for all of those 1,000 number, so we are trying to give basically a date. So index wise, so we are trying to create a data frame in general. So again, already we have discussed this function so many times in your Pandas class. So here we are trying to generate 1,000 a date. That's it. And then column name we are trying to give as a values, as simple as that. And here, so we are trying to create one series. So simple. So we are trying to generate 1,000 random numbers. We are trying to assign the indexes, our own custom indexes. If you are not going to assign your own custom indexes, so in that case, system will try to assign the indexes by itself. So we have created a data frame over here, and we have created a series over here, and we'll try to plot this data frame. We'll try to plot this series. So we'll try to understand that how it looks and how we'll be able to plot it. So it's completely fine. This is how my data frame is. So I have a value column and I have a date as an index in this particular place. So what I can do is, so I'm just trying to perform some small computation on top of that. A very small computation I'm trying to do on top of that. So let me try to print only this head value so that I will be having a limited data. So here we are trying to call a cumulative sum. So cumsum. Cumsum is just a function. So we try to give you a cumulative sum. So I'm trying to select this value column. I'm trying to do this cumulative sum over here. So cumulative sum is nothing but it's a summation of a current data set with the previous data set. So basically, if I'm going to execute it and if I'm going to call a cumulative sum over here, so as you can see, the first data set that we are able to get is exactly same. The second data set that we are able to get over here is nothing but it's a summation of this data set plus the data set. Now the next data set that you will be able to receive, so that will be a summation of the previous and the previous to previous data set. So we are just trying to get some of the computation. So even if you're not going to do these things, it's completely fine. So here we are just trying to do a cumulative sum and we are trying to get a data frame out of it, I can say. Now we are trying to perform a same kind of operation for the series data that we have generated. Here I'm just trying to show you that how you will be able to check a data type. So we have done the same thing many times, I can say. So here one of the data set which I have created is having a data frame, and other data set which I have created is having a series kind of a format. Now on top of that, so I'm trying to call this data series that we have created dot plot. So it's a very basic function. It's a very simple function at the same point of the time. So I'm trying to call this plot and then I'm trying to give a figure size over here. So whenever I'm going to call this series plot, so this is the series data set that we have, as you can see. So this is the series data set, and as you can see over here, so we have our indexes and we have some values. We have some indexes, again we have some values over here. So whenever you're going to call this series dot plot, it will try to plot each and every data set into X and Y plane. So a simple statement we can make over here is, so whenever we have to plot something into 2D, so if I have to plot a dot, so I need X coordinate, I need Y coordinate. So if I'm able to give X coordinate and if I'm able to give Y coordinate, I will be able to plot any kind of a data. Now, if I'm talking about a line, it's nothing but it's a combination of a dot itself. If I'm talking about any kind of a zigzag line, so everything is basically a combination of, I can say, a dot. So at any point of a time, my whole idea is to get a dot, get a points, or get a coordinate, a 2D coordinate, I can say X plus Y value. And then if I'm trying to represent those things over a 2D axis, I will be able to do that without any hassle. So fine. I'm trying to perform a similar kind of objective, similar kind of approach over here. So I'm trying to call this dot plot. I'm trying to give a window size over here. Window size is nothing but the size of this screen in which you are able to see the plot. Now, so if I'm going to do that, so after execution of this operation, so as you can see, So it is able to plot a graph. Now, so whenever it is trying to plot a graph, so it is trying to represent something into x-axis, it is trying to represent something into y-axis. Now, so let's try to understand that, because we are going to do a repetitive job again and again. So as you can see in your x-axis, so we have taken a date, and in your y-axis basically, so we have taken this data set. So whatever data set we have, so we have taken those data set into our y-axis. So by default, whenever you are going to call a data dot plot, so it will try to consider all of your indexes as a x-axis. So whatever indexes we have given over here, so it is trying to consider this as a Jan 2020, July, Jan. So these data, it is trying to convert all of those things into Jan, Feb and all those things, because this data was a date range data. So it will be able to understand all of those date range data. It will be able to convert it. And in a x-axis, so basically for this date, so this is the value. So for January, suppose this is the value. So it is just trying to represent over here. So this is the y-axis in which it is trying to represent the data set. Again, so for here, so it is trying to represent the data set. So it is trying to represent each and every coordinates, I can say, which is available inside your data set. And then, so it is trying to plot each and every things in terms of a dot. It is trying to combine each and every dots, and then you will be able to see some of the same. So this is the data pattern that you will be able to observe. So you will be able to observe that, so sometime my data value is increasing, sometime data value is decreasing. So it was on a peak. So whatever data we have generated, so my data was on a peak on January 2021, I can say. And otherwise, so like it is not in a peak. So it is like sometime it is decreasing, sometime it's increasing. So fine. So this is the one way by which you will be able to plot a graph, by calling a data dot plot and then by setting up a figure size. Again, if I'm going to set like 5 × 5 over here, you will be able to see that the figure has changed over here, and now it is trying to represent a same graph into a small figure. So it depends upon your Windows screen size, I will say, and depends upon what kind of a data set that you are looking for, what kind of a graph you are looking for. You can increase or decrease a size of the window. Now here, I have called a data dot plot. You can call plt dot plot as well. Now, if you go and check, so plt is nothing but it's basically alias for matplotlib pyplot. So in both the ways, you will be able to plot your data set without any hassle, without any problem. So yes, we are able to plot our data set. We are providing data set over here. If I wanted to set a figure size, I will be able to do that. So I will be able to perform each and every operation. It doesn't matter at all. So I will be able to give each and everything. There are so many parameters which I can adjust, which I can change, and which I can manipulate at any point of a time. Now, so again, what we are trying to do is, so we are trying to call a data frame dot plot. So data frame, it's the same kind of a data frame that we have created. So we are trying to give data frame dot plot. And if I'm trying to do that operation, so again in an x-axis, so it is trying to represent your indexes. In a y-axis, it is trying to represent your data variations. And this is the data that you will be able to get, I can say. Now, so anyone who is having any questions, so please go for the question after that. So we'll try to take it ahead.
Yeah, actually my question is regarding for if we wanted to be a show the level value on the particular chart, then how we can implement.
Yeah,
Actually,
so we'll talk about that. So all this beautification and everything will come into picture, as you can see,
okay.
right? So as we move forward, so we'll try to talk about all those beautification part.
Okay. So actually, why we are using the if we are having the already tools is there in the market, ClickView and ClickSense tools is also
So
is there.
basically, as a data scientist, the tool that you are talking about, so that is not being used by a data scientist, I would say, because it's not a responsibility of a data scientist to plot a graph or to like plot a chart or to generate a reports. That is basically a low level job, which has been done by a data analyst, I would say. So as a data
Okay.
scientist in a Pythonic way, I can say, or in a coding through a coding approach. So at any point of a time, whenever you have to get the insights of the data, basically. So as a data scientist, you will be able to get the insights, because sometime maybe by looking into a data pattern, you will not be able to understand. By looking into the numbers or looking into the values, you will not be able to understand. But at the same point of a time, if you look into the graph, you will be able to understand in a better way. That's the reason. So data scientists should know some of the Python libraries, but yes, they are not supposed to know all those tools that people use generally, a TabView or a Power BI, or I can say a ClickView or a Javelin kind of a tool.
Okay. Actually, basically, I am working as a ClickView developer. That's why I am asking.
Yeah, so basically, that is a low-level job we used to say,
Yeah.
and generally, that is a job which has been done by data analyst, not a data scientist.
Okay.
This plot
So
function is basically from Matplotlib library, right? Or Seaborn?
So matplotlib as of now we are talking about.
Okay.
So you can use matplotlib, you can use Seaborn, you can use Plotly, you can use couplings, you can use bokeh, you can use a DJ3, so everything. So you will be able to use any of these libraries and you will be able to plot a graph. So the whole idea behind plotting graph is to find out the trend of the data. That's it. Yeah.
the figure size is 5 means it is x and y axis.
Size of the box, I can say. So X into Y we are talking about.
So, Sudhanshu, all these libraries which you mentioned, I mean, they more or less they'll have same similar functionality.
Almost every libraries. So here we are going to talk about like a matplotlib, Seaborn, Plotly, and couplings, right?
Right.
You will find out that almost every library is having a same kind of method. Almost.
Okay.
Right. So if you know one library, you will be able to learn other libraries in a quickest possible way. Just within an hour, so you will be able to learn other libraries as well.
Okay.
Sudhanshu, the plot function.
If we have multiple, the data frame that you have discussed is we have only one value, right? If there are multiple values,
I think we have just started, right? So just wait for some time for those questions. Yeah.
okay.
Sudhanshu, the plot function in pandas as well as matplotlib, is it the same?
Which one?
You have called the plot function using a data frame as well as using the matplotlib as well, right?
Yeah, so I have called plot function by using a data frame as well as
the PLT. That's an extraction from.
Yeah, that is completely fine. That is same.
So both will be having the exact same functionality.
Exactly. Yes.
So
yeah.
before using Matplotlib or any other this visualization library, I mean, we need to import pandas and always, right? I mean.
No, so if you are having a data set in a data frame, so for sure you will have to import pandas, right? Otherwise, how you will do a data manipulation?
Yeah. But otherwise, I mean, we can do without pandas also. I mean, if it is not in data frame or maybe.
Yeah, in that case. Fine, moving ahead.
Sudhanshu, one question actually.
So here, basically, let's talk about these things. Okay, let me share my screen. Fine. So here, as you can see, so we are trying to plot this data over here. Okay, so my screen is giving me some problem. Okay, so here what we are trying to do is, so we are trying to call SNS.load dataset. Now, so here we are trying to load a very simple dataset. I can say Irish dataset. So Irish dataset is a open source dataset, I can say. Most of you must be aware about that. And here, so we are trying to call load dataset and Iris. So by default, it will be available inside your libraries. Again, so at same point of a time, you will be able to download a hard copy of that. You will be able to download actually a copy of that, I can say, from our internet, and then you will be able to load it. So here we are trying to load this Irish dataset, a simple one. So in this Irish dataset, so you will be able to find out basically a 4 feature and 1 label column. So here feature wise, you will be able to find out sepal length, sepal width, petal length, petal width, and species wise, so you will be able to find out Setosa, Virginica, and versicolor. So these are the 3 species you will be able to find out in a species column. So if I'm going to execute this one, and if I have to plot this one, this graph, basically, so if I have to plot this data set, so what I can do is, so I can try to call irish.plot, just in the same way we have called dataframe.plot. So I'm trying to call this dataframe.plot, and then I'm trying to set a figure size. Figure size again depends. So like what kind of a X cross Y window I'm looking for. And then I can try to give a title. So suppose if I wanted to give a title of the graph. So here, so in the simplest possible way, so I'm trying to give a title of the graph. So yes, it is able to give a title of the graph like Irish dataset. as you can see over here. And then if I wanted to set a X label and Y label, so if I wanted to give a name to X axis and if I wanted to give a name to Y axis, I will be able to give those names to X axis as well as I will be able to give a name to Y axis just by calling set S label, set Y label, and here I'm trying to call a title. So here I'm able to give a title to this particular graph. So all of those operations, whatever fancy operation you wanted to do, you can do that at any point of a time. So all of those libraries are available. I can say APIs are available inside this library. So here, so whenever I'm going to call this iris data set dot plot in this place, so it is going to plot all the numerical columns. So whatever numerical column you have, so it is going to plot each and everything. It is not going to plot a species column at all. It is going to plot a numerical column. Now, so if you will observe over here, so it is trying to plot all the numerical column. That is completely fine. In an x-axis, so it is trying to take the indexes. So always by default, so in an x-axis, so it is going to consider indexes of the data frame. So whatever indexes you are having here, so it is trying to represent all those things into x-axis. And then in a y-axis, so it is trying to represent the values basically over here. So you will be able to find out that here, so it is a values that it is trying to print out. Now, so here you will be able to see that it is trying to represent a notation. So which color is representing which column. So as you can see over here, so petal width. So yes, this red color is representing a petal width. Petal length, green color is representing a petal length. Then sepal width is represented by orange color. And then sepal length, so sepal length is represented by this color. Now, so just by looking into this graph, so you will be able to find out some of the observation. So I will be able to find out that, okay, my petal width, which is nothing but a red one, so it is fluctuating in between maybe a 0 to 2. So the maximum max to max petal width you will be able to get is 2, and a minimum petal width that you will be able to get is around 0, close to 0, I can say. Now, so if someone will ask me about this blue data set, which is nothing but a sepal length, so I can simply say that, okay, so sepal length can vary in between 4 to 8. This is what I can see over here. So you will be able to do all of those observations just by looking into a graph at any point of a time. So this is where a visualization can help you out to understand a pattern of the data set. And here, so we are able to visualize a multiple column at single point of a time. So here, as you can see, so in your x-axis, so you have basically indexes, and in your y-axis, so basically you have a values. Now, so here, so we are trying to plot a very simple graph, I can say, a line graph. Now here, so we are trying to call a different kind of a graph. So even graph wise, so you will be able to find out that there are a different kind of a graph which exist. And you will be able to plot all of those different kind of a graph at any point of a time. So let's try to understand it and let's try to plot. So far so forth, we have been plotting a different kind of a graph. So here, so I'm going to plot a bar plot, basically a bar graph I'm trying to plot. So here I'm trying to call my data dot plot kind is equal to bar. So same data. So what the same data that we have taken into our series. So same data, I'm trying to plot it as a bar over here. Now, so here what we are trying to do is, so we are trying to call our iris data set. We are trying to drop our species column because that was basically a categorical column where we were having like a sepal and sepal width, like a Virginica, sedosa and versicolor. So sepal and sepal width, petal and petal width was having like a numerical data set. So on axis 1, so we are trying to drop this column as of now, as you can see. So after dropping this column, so this is how it looks like. Now, so suppose what we want is, so suppose we wanted to plot a bar graph, I can say. So to plot a bar graph, so I'm trying to call a data frame.ilog. I'm trying to select basically a 0th row over here. So I'm basically trying to select this row, as you can see in this particular place. And then I'm trying to call a plot. And then as a kind, so kind wise, I'm trying to call bar. So if you are not going to give a kind over here, so in that case, it is going to print a default one. So default one means line graph, it is going to plot. So here what will happen is, so if I'm going to execute it, so it is going to give you this kind of a graph where we have a sepal length, we have a sepal width, we have we have a petal width, petal length. And then, so depends upon the values. So depends upon the values. So in a y-axis, it is trying to represent the magnitude. You can see it's going till 5.1. The second one, sepal width is going till 3.5. Petal length is going till 1.4, and petal width is going till 0.2. So this is how you will be able to plot another kind of a graph, which is a bar graph. So likewise, there are many more graphs which is available, which we are going to execute and which we are going to see. So yes, it's the same thing that we are trying to plot. Now here, so we are trying to load another data set, identity data set, I can say. And here, so we are trying to plot a graph based on some of the columns, I can say. So here we are trying to select a passenger class column, a single column that we are trying to select, and then so we are trying to call plot. Now, so inside this plot, so we are trying to say that kind is equal to histogram or hist, basically. So we have seen a line graph, we have seen basically a bar graph. Now the third kind of a graph that we are looking at is histogram. Now let's try to understand that what is the meaning of histogram first of all. So if I'll try to select this passenger class, so passenger class is having three different kind of a class: class 1, class 2, and class 3. Now, so if I'm going to give class this kind is equal to histogram, so in that case, what will happen is it will try to find out a distinct element. So distinct element inside this passenger class will be 1, 2, 3. It will try to find out the count of this distinct element. Suppose count of one class 1 is equal to 200, count of this class 2 is equal to maybe 150, and count of class 3 is equal to maybe 500. So it will try to find out the count of that particular data set, I will say. So in a x-axis, it is going to represent a data like 1, like 2, and 3. It is trying to represent. In y-axis, it will always represent the magnitude, means number of occurrences of the data or count of the data for that particular group. So you can say that it always try to perform a group by count operation kind of a things, or else you can say that, so histogram always try to represent a data into x-axis and its frequency of occurrences, I can say, into y-axis. So whenever you have to like do a group by count kind of operation, if you wanted to know that, okay, fine, how many groups I have into a particular column and what is a frequency count of each and every column, you can do that. You can just directly call this histogram, and then you will be able to perform all of those operations easily. So this is where histogram comes into the picture. Again, this one is one of the most popular graph that we use to plot, I can say. Now here, so what we are trying to do is, so we are trying to call pandas.dataframe, and then here, so we are trying to call rand-in. Rand-in wise, so we are trying to give 10 cross 4. So 10 row and 4 column we are trying to generate over here. And we are trying to give a column name as well in this particular place. Here, so we are trying to give a data frame.head. So we are trying to showcase only 10 data sets. So it's completely fine. So we have generated this random, I can say, a data frame. Now let's try to perform some operation. So here we have generated this data frame. So I'm trying to call data frame.plot.bar. So bar we have already seen. So plt.plot, and again inside that you will be able to pass a bar, or else simple data.plot.bar. You will be able to call it, and then you will be able to get this kind of a thing. So in case of a bar plot, as we have already discussed over here, so in case of a bar plot, so it will simply try to represent actual data set in a, so or data indexes, or maybe a kind of a column name into your x-axis and the actual magnitude into y-axis, I can say, in case of bar plot. Now, so here we are trying to do a same kind of operation. So if I'm going to execute it, so as you can see over here, so in our x-axis, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, means we have our indexes. And on our y-axis, I can say, so we have basically a data range. So here, if you will try to look into this closely, so you will be able to observe some of the events in this particular place. So let me just try to show you a 5 data set. Then I will be able to show you these things. So here you will be able to see that on index is equal to 0. So on index is equal to 0, we have A column, B column, C column, D column. So on index A is equal to 0, 0th indexes I can say over here. So it is trying to represent all these 4 columns. So A column represented by blue line, orange line, green line, and red line. So A, B, C, D, basically. So here, as you can see, value is equal to minus 1.14. So yes, it is trying to represent minus 1.14, I can say, in this axis. Now B is equal to 0.47. So yes, B is equal to 0.47. C is equal to, I can say, minus 1 dot, so minus 187. So that is a bit wrong, I can say. So green line should not be this one in the 0th axis. Let me execute it. So in that way, it will be fine. Yeah, so now you are able to get the exact graph, I can say. So here, as you can see, I have minus 1.4. So yes, I have minus 1.4. B is equal to 0.47. B is equal to 0.47. C is equal to minus of 1.87. So yes, it's minus of 1.87. And D is equal to 0.08. So yes, D is equal to 0.08 for the index is equal to 0. For index is equal to 1, 2, 3, 4, and so on. So you will be able to plot this kind of a graph. So this is just a bar plot where in an x-axis it is trying to represent your indexes, and in a y-axis it is trying to represent your magnitude. That's it. Now here, so again, like I'm trying to show you a bar plot. Now, so there is something called as a bar H. So it's again similar to the bar plot, but yes, it is just trying to show you a data from the flip side. Means it is trying to rotate the same bar plot by 180 degree, and then it is trying to show you the data set. That's the reason it's called as a bar H or bar horizontal, basically. So the full form of this one is bar horizontal. Again, so we are trying to plot this iris data set, I can say. So we are trying to call iris.plot.histogram, and we know that inside this iris data set, so we must be having a 4 different column: sepal length, sepal width, petal length, and petal width. So we know that in a histogram, so it always try to represent basically a data range on a x-axis, and on a y-axis, so it always try to represent the frequency or frequency of occurrences. So this is the same thing that we are trying to observe over here. So we are trying to call iris.plot.histogram, and in this case, so you will be able to observe that. So we are having almost, I can say, 100 number of data set which falls in between this to this, which is having a magnitude. So we are having almost 100 number of such sepal width, because this orange color is represented by sepal width, whose value will be in between this to this range. So this 100 is basically a frequency, and this is just a range of the data set in which it is going to occur, I can say. Now here, so again, it's the same thing that we are trying to call. So either you can call it like a data.plot.histogram or data.plot and kind is equal to histogram. So even in both the cases, so you will be able to get the same kind of a output. Now, so here, so I'm trying to call like iris.plot, kind is equal to histogram, stacked is equal to true, and width is equal to 50. So here we are trying to control a different parameters, I can say. So whenever I say bins is equal to 50, so it means that it is trying to show the thickness of the entire graph. So whatever graph it has plotted, so it is just trying to showcase the thickness. And if I'm talking about the stacked, so stacked means, so if I'm going to make this as a false, so you will be able to see a very clear observation over here. So whenever I say stacked is equal to false, so it is trying to hide the overlap. Whenever I say stacked is equal to true, so it will always try to show the overlap. So these are the things which is available. Again, so we are trying to call iris.plot, kind is equal to histogram. So we are trying to plot basically a histogram, stacked is equal to true, bins is equal to 50, orientation is equal to horizontal. So you will be able to plot a graph horizontally, or you will be able to plot a graph vertically in this particular way. So this is how like you will be able to plot a horizontal graph, you will be able to plot a vertical graph. So anyone who is having any issue, any concern, so please go for the question. Yeah.
So Danshu, what kind of graph should be used in what kind of scenario? Can you please
it
tell
depends.
us that?
It depends. Suppose if I just have to see the scatterness of the data, so in that case, I will go ahead with the scatter plot. Suppose if I have to find out that, okay, so what is the frequency of this data in between this to this range, I will go ahead with the I will go ahead with the histogram, I can say. Suppose if I have to know that, okay, fine, so what is the magnitude of this data set for this particular indexes, or how my data set is varying, I will go ahead with the bar chart. if I have to like find out that, okay, fine, so what is a area or what is a probability it is going to take, so maybe I can go ahead with the pie chart. It depends basically. So depends upon your requirement that you have.
Sudhanshu, can you scroll up a bit up? No, up. Up. Yeah, down. Yeah, this one. Yeah. So this one plot bar, right? I mean, here we saw that basically a data frame, right? It has four. I mean, if we see the x-axis, so basically we just have four records, right? Four columns. I mean,
Yeah.
but I mean we have taken till 9. So, but I mean, our data is represented between 0 to 4. I mean, the entire data, right? It's A, B, C, D.
Yeah, so in for every index, it is trying
Yeah.
to print ABCD.
Right, but why it is printing till 9th index? I mean, that I didn't.
Have I taken data frame of 4 over here?
No, but
I have
No, it
taken
is 0
entire
to
data frame.
10 values.
I have taken entire data frame, right?
okay. I thought it is just above. Okay, it's head
Here I'm
of
just
5.
trying to show you this data. That's it.
Okay.
This color coding can be changed in place of red if I want blue or like that.
So
Any
there is
property.
a color control as well. So you will be able to change the colors, whatever fancy things you wanted to do. So
Sudhanshu, can you please go slowly?
I think I'm already going very slow, right?
Yes,
I don't know. I feel something fast.
No, I don't think so. So we can take a vote from the people. So I'm already going very slow.
Okay.
Yeah.
What is the difference between bar graph and histogram?
Okay, so I think I have explained you twice or thrice bar graph. I have seen your message as well. Pallav, right?
No.
Okay, so yeah, try to keep your eyes open for some time. So basically, a difference between bar and histogram is, so in a bar, so it will try to represent your magnitude of the data in a y-axis, I would say, whereas into a histogram, so it will try to show you the frequency, basically. So in x-axis, so suppose if I'm trying to take again another example, so in case of a histogram, if I'll talk about, so in histogram, so in your x-axis, so it will always try to take a range, and in between this range, whatever is the data you will be able to get. So your y-axis always represent the frequency, I can say. Whereas into a bar, if I'm talking about, so in case of a bar, so x-axis is going to represent your indexes or whatever notation you have, and your y-axis is going to represent just a magnitude, not a frequency. That's a difference.
Why you are loading the data frame with Seaborn? You can't load it with Matplotlib?
In Matplotlib, dataset is not available. So there is a dataset, some of the default dataset, which is available with the Seaborn, with other libraries as well. So you will be able to load it. Otherwise, like I said, so all of those datasets are open source dataset. You can search on Google. You will be able to download as a CSV file, and you can load it as a CSV file. Okay. So even that is fine. Ultimately, we are looking for a data frame. So you will be able to get data frame in either way.
No, Sudhanshu,
And
the
sir, in a
function basically.
histogram chart, we are using a bins. Bins is
No, your
equals to
question is
50.
not clear actually. So whoever is speaking.
In histogram chart, we are using the bins. Bins is equal to 50. What are
Yeah, so bins is equal to 50 simply means that the width of the graph means whatever chart it is going to represent. So if I'm going to make bins is equal to 100, you will be able to see a very clear differences over here. Are you able to observe it?
Yes.
So just about the thickness, as I have said. See. Okay. Fine.
Yeah, hi. One question, Sudhanshu. Yeah, basically, I'm just saying like the function which you use to load the data set is actually with Seaborn, right? So can we use similar thing with Matplotlib?
The dataset is not available in Matplotlib. So how you will be able to use it? Like I said, so these are the default dataset which comes with the libraries. So again, I'm just trying to show you this example. That's the reason. So I have taken this dataset, default one, and then I'm trying to showcase. If you wanted to use your own dataset, you can use your own dataset. And in a real time, so for sure you will be using your own dataset. So just to showcase this thing, and ultimately I'm trying to do whatever operation I'm trying to perform over here. So I'm trying to perform all of those operations based on the data frame itself, right? So it is not going to matter that whether you're loading a data set by default from a libraries or you're trying to load data set externally from somewhere else. It's just a data frame operation that I'm trying to perform, nothing else. Okay, fine. So moving ahead. So till this point, so we have discussed. Now here, so we are trying to call iris. We are trying to select only one column separated in this particular place, and then we are trying to call diff over here. So diff is nothing but it is trying to show you the differences. So differences between the previous one and the latest one. So just a simple observations, a simple, I can say, a calculation that we are trying to perform on top of that. Now, so here we are trying to call this diff, and then we are trying to call plot. So for sure it is going to give you this kind of a data that we have already received. Now we are trying to call plot. So we wanted to do a histogram plot. Stack is equal to bin is equal to 50. So I think we have seen this kind of things so far, so forth. So in case of a histogram, you will be able to find out that in an x-axis, so it is trying to represent basically a range, and in a y-axis, so it is trying to represent a magnitude. So frequency, I can say. So it is going to tell you that, okay, fine. So this data has occurred this many number of times. Whereas if I'll talk about a bar graph, so it directly represents a now. So again here, so we are trying to perform some other operation. So here we are trying to perform data frame dot difference. So here we are trying to load iris data set. We are trying to remove this species column from the iris data set because this column was having a categorical data. So we don't need that. We just need a numerical data because we have to plot it. So here iris dot drop, and we are trying to drop this species, I can say, and this will be the data frame. Now, so data frame dot diff, and again I'm trying to call a histogram. So last time basically I have called a histogram on top of a single column, I can say. So this time what I'm going to do is I'm going to call a histogram on a multiple data set, I can say. So here is the thing. So here what we're trying to do is, so whenever you are going to call a histogram, yeah, so here, so here what we are trying to do is, so we are trying to call this one, and then histogram we are trying to call. So already we have seen that there are 4 columns which is available inside my data frame: sepal length, sepal width, petal length, and petal width. Now, so we are trying to give a color B is equal to blue. So you will be able to change any colors, doesn't matter. Alpha is equal to 0.1. So alpha is nothing but it's a brightness, I can say. And figure size is equal to 10 cross 10. So basically in 10 cross 10, so I'm trying to plot each and everything. So as you can see, this is that graph you will be able to get. Now, if I'm going to increase the alpha value, you will be able to see a more darker shade. So here you will be able to see that this, we have plotted a 4 graph in this way because we have passed a 4 different columns over here. And we are trying to plot petal length, petal width, sepal width histogram separately in this case. And again, so color blue, red, whatever you are looking for. So you will be able to pick all of those colors. You will be able to give a color code as well over there. And you will be able to print and plot each and every graph. So again, the same old histogram we are trying to plot, but yes, separately. So for a different columns, so we are trying to plot these histograms for all of these 4 columns. Now, so again, there is another kind of a plot called as area plot. You will be able to observe. So area plot is nothing but it tried to represent this entire data. So whatever data which will come below that particular graph, it will try to take, or it will try to just paint it basically, and will try to cover that entire area, I can say. So there is something called as an area plot. You will be able to receive, you will be able to get that. So here, as you can see, so we are trying to plot based on the area. Someone is saying that I'm not audible. Am I audible to everyone? Yes. In that case, you can check your net connectivity, Gopinath. Now, so again, so I'm trying to call area and stacked is equal to false. Basically, stacked is equal to false simply means that it will try to show you some kind of a transparent data, some kind of a transparent graph, basically. So area's graph has not been widely used, I can say. Generally, we use a histogram, we use a bar plot, we use a scatter plot, we use a line plot. So these are the kind of plot in general we are going to use. not this area kind of a thing, but still it's another kind, it's one of the kind of a graph. That's the reason. So I'm just trying to show it to you. Now here, so we were talking about scatter plot. So here we are trying to call data frame dot plot dot scatter. And here I'm trying to give my x-axis and my y-axis separately. So here I will be able to pick and choose basically my x-axis column, and I will be able to pick and choose my y-axis column, and based on that, so I will be able to plot a graph. So I'm trying to call like a data frame dot plot dot scatter. X-axis, so in an x-axis, so I'm trying to give a sepal length. In y-axis, so I'm trying to give petal length. So if I have to know that what is a relationship in between sepal length and a petal length, so maybe I can go ahead with the scatter plot, because whatever data we have inside sepal length and petal length, so it will try to consider one as a x, another one as a y, and then we'll try to draw all the dots. And here you will be able to observe that there is some relationship we have. So if I'll talk about this pattern, so when sepal length is increasing, petal length is also increasing, I can say. For this range of the data, I can say that sepal length is increasing, but petal length is not having that much of variation, or it's not having that kind of a linear relation, I can say. So this is where this graph of visualization comes into a picture, where you will be able to get some insights. You will be able to understand that how one data is going to vary with respect to other set of a data set at any point of a time. So fine. So we are able to perform this scatter plot kind of a things, and yes, it is working fine for us. Now here, so you will be able to find out like a data frame dot, I can say plot dot scatter. So here what we are trying to do is, so again we are trying to call a sepal length and petal length, and here we are trying to call a sepal width, I can say. So here three things we are trying to call, as you can see over here. So we are not only calling a 2 column, so we are basically trying to call a 3 column over here, a sepal length, a petal length, and a sepal width. So this column, the C column, or the C value that we are trying to call over here, so it is just trying to represent a magnitude on the color scale, I can say. So as you can see over here, in case of sepal width, so here it is starting from a very light color, and then it is going till dark. And here we are able to see that sepal width range is having starting from a 0 to 5, I can say. So this one, 5 or 7, somewhat like that. So 5 maybe. So here, so sepal length is varying in between 2 to 5. Now, so how you will be able to understand this kind of a graph, basically. So here you will be able to find out that I have a sepal width, and here a sepal width is having a very light color, then again bit darker, and again, so it is too dark over here. Here in your left hand side, you will be able to find out this kind of a graph, and somewhere you will be able to find out a faded color. Somewhere you will be able to find out a darker color. Last time we have plotted the same thing, but we have not used a third column. This time we are using a third column, and basically we are trying to plot this data which is relative to a third column, I can say. So here I can say that here this color is lighter in this case. So wherever and whatever sepal length versus petal length you are able to get, so that sepal length versus petal length is having sepal width in between this range. This is the meaning, I can say. So this is just a relative scenario where you will be able to observe that, okay, so how this data will vary if this data is varying in this way. So here you will be able to observe that how sepal length versus petal length will vary in terms of a data value. I can say when this is the sepal width, when sepal width is darker, when sepal width is high. So I can say that when sepal width is too high, so in that case, my petal length and my sepal length, so both are low. I can say that. When I can say, just by looking into this observation, I can say that when my sepal length and petal length was too high, my sepal width was low because color is not that dark, I can say. So this is the kind of observation you will be able to figure out, you will be able to find out of the data set. So this is the kind of insights you will be able to get, that how one data set is varying, or magnitude of one data set is varying when other data set is trying to move in this direction or in that direction. So anyone who is having any question, go for that.
Hi, Sudhanshu.
Yeah.
Going back to the histogram where you were showing 4 different histograms.
Okay.
So I've seen one of the previous examples where all the histograms were overlapped on top of each other. So
yes, yeah. So here we have called data from dot histogram, especially we are calling, right? Okay. And on top of the data frame, we are trying to call in this case. Now here, so if I'll try to show you these two things parallelly. Okay, where is my histogram? Okay, so are you able to find some difference?
There are 4 different arrays in it.
Which one? No, the only thing is the way I'm trying to call it, right?
Yes.
So if I'm trying to call data frame dot hist, in that case, it is going to plot a 4 different graph. If I'm going to call data dot plot, and then inside that, if I'm going to fill that as a kind, so in that way, I will be able to get all the histogram into a same graph.
Okay, okay. So even for iris, if we call it in the similar way, it will be
in both the places, I'm trying to call the things for the iris, both the places, right?
Yes.
Even over here and even over here. So I'm trying to call these things for the iris dataset itself, right?
Okay. Yeah, yeah.
But here it's for difference, right?
Yeah, the difference is only in terms of a representation, I can say, nothing else. So here it is trying to showcase all the data, all the histogram into a single graph itself. So there is a overlap. And here I'm just trying to separate it, right?
Okay.
And then I'm trying to plot a graph. That's it.
And
we give different colors for this.
Sorry?
For all this four plots, can you give different colors?
You will be able to use any kind of a beautification. So whatever you can think of, right, in terms of beautification, you will be able to do that.
Oh, we can do it. Okay.
Yeah.
And Sudhanshu, in the last scatter plot that you were talking about, what exactly does the parameter C signify?
What exactly the
parameter C indicate?
Okay, parameter C indicates a third axis, I would say. So here we are just trying to represent a third axis. Okay, just wait. I have to ask something. Yeah, so we are installing some of the equipment here, so that's the reason. So there is a sound. Okay, so someone was asking me that what this C signifies, right? So basically, this C is nothing but it is going to tell you the Z axis, or I can say third axis. You will be able to give with the help of C. So basically, C always try to signifies that a color changes or a color variations. So it will always try to give you a kind of a bar. So where it will try to take a different colors starting from a low range till high range, and it will try to tell you that, okay, so basically if I'm talking about this data set, so basically this data set is a representation of sepal length and petal length. Yes. So here sepal length and here we have petal length. Now, so if I am asking you one question, a very simple question, that okay, tell me that if the sepal length and petal length varies in between these to this range, then what is the range of sepal width, right? So you will tell me that, okay, fine, sepal width range will be in between, somewhat in between this range. Can I say that?
Yeah.
Yeah, because it's a darker one, right?
Yes.
So to answer this kind of a question, to answer a relative question, I can say with respect to some other columns or with respect to some other axis. So generally we use this kind of a parameter C. So in C, so you will be able to pass any columns that you have, and based on that, so it will try to vary the other data set on a x-axis and on a y-axis. Fine.
So the only way to indicate a third axis is using a color gradient, or we can do some other way as well?
We can do, so we can go ahead with the 3D plot in that case. So 3D plot, I will be able to show you for sure into Plotly and into cufflinks. So that is also a way to represent the same thing. So here I'm going to show you like some interesting kind of a graph where you will hover your mouse and see this 3D plot. Yeah.
Sudhanshu, one question. In one of the histograms, you showed stacked is equal to true.
Yes.
Can you explain that part as to why we are stacking?
A stack is equal to true simply means, so it will try to give you, or it will try to show you data one on top of other. So you will not be able to, if you are trying to make a stack is equal to true. So in that case, so if suppose there is some data, there is some overlap, so it will try to show you a graph which is behind another graph. So it will try to show you a bigger one, then a smaller one as well. Otherwise, it will just try to show you the bigger graph. So for example, so if I'm trying to, so that is the meaning of stack. So suppose if I am trying to plot a graph over here, basically, so this is my one of the graph. Now, so suppose I have another graph, which is like on a top of same graph, I would say. So here, suppose this is the bigger graph and this is the smaller graph. So if stack is equal to false, so in that case, you will not be able to see a red one. It will be able to hide it. If stacked is equal to true, in that case, you will be able to see a red one as well as you will be able to see the big one, both. So that's the reason. So we are using stack is equal to true or it's equal to false. It's just a parameter. Making sense?
Yes,
Sudhanshu, one more question. I mean, can you tab on to the plot, the last one where we are verifying it through the colors?
Sorry?
Yeah, this one. So my question is, how reliable is this color thing? Because if I have my value somewhere like 3.2 and my other value is 3.8, so color difference by looking will be very
So in case of, I would say, so in case of a graph, right? So we don't look for the aggregate values, or we don't look for the precise values. We always try to look for the relative values. Can I say that?
Yes, but if you see the difference in color between 3.0, 3.5 and 3.5, 4.0, it's very less. So
yeah, it's very less. That's completely fine. So we can say, we can make a claim over here that, okay, so basically like it is even if we are taking a sample length starting from a 0 to 3, right? A range of 1 scale, I can say. So in that case, so data set is not varying much, or I can say that I can make a claim over here that for sample length in between 2 to 3, right? So all of those data, so whatever data you are going to plot over here, I can simply make a claim that whatever data we have plotted in this range, which is having a sepal length and a petal length relation, a linear relation kind of a things. So for that, sepal width will be in between range of 2 to 3. So just been used for the relative study, I can say. You will not be able to get a precise values from the graph. So the graph has been used just to see the patterns, right? If I have to give you the exact value, why I would plot a graph? So basically, I will go ahead and I'll give you, I'll start the data, I'll give it to you.
Yeah. And we can have colored graph as well. I mean, it's
you can like put any kind of a color. There is no problem with that. So you can, like, all those fancy things are possible. So again, in my previous Matplotlib, IP file that I used to discuss in some other batches. So in that batches, so I have mentioned all those fancy things. Slide was too huge. It used to take like 2 to 3 days just to discuss Matplotlib. I have just removed each and everything. So if you want, I can just share these things in your dashboard so that you will be able to get all the fancy things. But yeah, for the data scientist, that doesn't matter. Unnecessarily, you will end up wasting your time. So for the data scientist, the things which matters is how to plot a graph. You should know that. So at least 4 to 5 kind of graph you should know. So you should know histogram, you should know bar plot, you should know scatter plot, you should know pie chart. So these are the normal line plots. So all those things that you know, because the main purpose behind learning this visualization for the data scientist is to understand the data pattern, nothing else, not to do a fancy things. Those fancy things will be done by your data analyst people, your data analyst team, which will be working not only this coding part, so which will be working into Tableau or some view or some Power BI kind of a tool where they will just do drag and drop and mapping. That's it.
Mm-hmm.
Sudhanshu, like from a scatter plot, what kind of deductions we can deduct? Like, actually, we are plotting like sepal length versus petal length, right?
Yeah.
Okay, by seeing the graphs, like previously we have plotted like bar graph scatter. Now we are plotting scatter plot. Like,
Yes.
what are the inferences we will get? Like huge
So,
data sets we are going to deal with, but
yeah.
what exactly kind of deductions we are going to get? What kind of questions we have to ask ourselves while plotting these graphs?
Yeah, so basically, as you can see over here, right? So observation wise, so in this one, so I am clearly able to observe that yes, there is some linearity between a sepal length and petal length, right? Above this point, I can say. So above this 3 and like beyond this 5, so I can say that there is some linearity. Here, I'm completely able to find out that no, there is no linearity in between. So even if like a sepal length is increasing, my petal length is not increasing, right? It's almost going to be constant. So these are the kind of insights we'll be able to understand and we'll be able to extract out of it. Yeah.
Yeah, for every data set, it is going to change, right? Like just
for everything, it is going to change. So yeah, so any data set you are going to plot over here. So maybe I'm taking sepal length and petal length. Maybe I can try to pick something else, some other columns. And even in that case, so you will be able to find out that it had changed.
Okay.
Yeah. So it depends upon your data variations. It is not going to be same at all. So maybe with respect to petal width, I will try to plot these things. And yes, it will change.
Hello.
Go ahead.
Sir, can we say this histogram is for categorical variable?
So as you can see over here, so we have plotted this sepal length versus petal width, right? And if we are trying to plot sepal length versus petal width, so you will be able to see that there is no exact pattern I'm able to find out. So I can say that, okay, so there is no correlation which I'm able to find out, exact correlation which is available in between. So basically these data are related, but these data are related, very oddly related data, I can say, right? So in this case, I will simply say that, okay, fine, no, there is no relation, so I'll not take it ahead. This relationship. Making sense, everyone? Yeah.
Yeah.
That's a kind of an insight. So you will just by looking into a data itself or just by looking into a plot itself, you will be able to get those insights. If I'll give you a direct data frame, right, you will not be able to understand that and you will not be able to think about those things. But if you look into this plot, right, easily you will be able to answer all of those questions.
So Sudhanshu, can we add another dimension to scatter plot? Like you have maintained 3 axes over there.
Yeah,
but can
so basically
we add another dimension like
so here
column?
I have added other dimension, right? How one data is varying with respect to these two data.
No, I'm saying about 4th column. Is it possible?
No, 4th column is not possible. Till 3D you will be able to plot, and I'm going to show you this 3D one into this plotly. So as you can see, so this kind of a 3D graph you will be able to draw, you will be able to plot. Yeah. So this is also a scatter plot. See.
Yeah.
But the only difference is, so it's having XYZ axis, see, over here, and that is like it's a much more beautiful and powerful graph than the graph that we are discussing as of now. But yeah, so till 3rd coordinate, so you will be able to draw the graph and you will be able to visualize it.
Sudhanshu, if you don't mind, can you please explain the dataset loading part once again?
Dataset loading part, which one?
The load dataset of Iris. So when you
say simple, so from the library, I'm trying to call the dataset. If you are finding difficulties with that, go to Google, try to type Iris dataset download. You will be able to get a very first link from where you will be able to download a dataset into a CSV format, into Excel format, into TXT format. Now, so we have already discussed these things into Pandas, that how to load a dataset into in a form of data frame from any other file system, right?
Yes.
So you can do it because in a real time, you're not going to use a default dataset, right? So
yes.
You're not going to use Iris dataset, you're not going to use strategy dataset. Basically, you will be using your dataset, right? Now we know that how to load a dataset, so fine, you can just load it.
When you mentioned Iris as an argument in the load dataset, where exactly is that Iris file?
Which one? So basically, it's file which is available with a SNS library. Okay. So what is the SNS? SNS is just an alias for Seaborn. So it's already a part of library.
Oh, okay.
I can say. Okay. So generally, these are the standard dataset used worldwide with by everyone. So people have included this dataset inside the library itself.
Perfect. Okay.
Okay. So moving ahead, basically. So here, categorical data plotting. Okay, no, I was not talking about this. Okay, so data visualization with Pandas. Fine. So here you will be able to see that I'm trying to plot one graph inside another graph. So basically I'm trying to plot a two graph altogether. So here you will be able to find out that I'm trying to plot a two graph basically altogether in a single graph itself. So here what I'm trying to do is, so data frame dot plot dot scatter. So basically I'm trying to do a scatter plot, and I'm trying to pass x and y. So x and y, sepal length and petal length I'm trying to pass, and label is equal to length. So I've already given label is equal to length. If I'm going to execute it, so this is the graph I will be able to get out of this one. Same old graph. Now I have stored this graph inside a variable, ax variable, I can say. Now, so I'm trying to plot another graph over here. So which is a graph about a sepal width and petal width. So last time it was sepal length, petal length. This time sepal width, petal width. I'm trying to give a label as width. And so I'm trying to assign axis is equal to axis. Means whatever variable we have created, we are trying to assign that as an axis. It means that whatever axis this has used, means whatever boundary boxes this has used, just use the same boundary boxes over here. That's it. Color is equal to red. So specifically for this one, color is equal to red. It is supposed to pick. So as you can see, so it is trying to represent, it is trying to plot this graph as well as it is trying to plot a sepal width versus petal width. So here you will be able to get two graphs at a time. So at any point of a time, you will be able to accommodate any number of the graph. Just you have to assign the axis of that particular graph, nothing else, and you will be able to get it. Apart from that, so you will be able to do so many changes. So there are parameters you will be able to find out by which you can do a lot of changes in this one. Now, so here I'm trying to call data frame dot plot dot scatter. I'm trying to give a sepal length and petal length over here and sepal width over here. Now, so here what I'm trying to do is, so I'm trying to give a size. S means simple size, I can say. So size wise, so you will be able to give any kind of a size. So let's suppose if I'm trying to give maybe 700 or something like that over here, you will be able to find out that, okay, fine, so this is the size. Now, so I can try to increase or I can maybe try to decrease the size. And in that case, it is going to give you that size of the circle, I can say. So here I'm just trying to make a variation with respect to a size. That's it, nothing else. Now, so here data frame dot plot dot hexabin. So last time we were trying to draw a scatter, so which is nothing but a circular shape. Now here this time, so I'm trying to perform the same thing, but yeah, like a hexabin I'm trying to call over here. So x dot sepal length, petal length, grid size is equal to 10. So I'm just trying to give the size of this entire grid, the hexabin that it is trying to consider, and c is equal to sepal width. So again, same kind of variations which we have already discussed, we are trying to give. So we are able to plot a hexabin kind of a scatter plot. Even that is fine, I can say. Now here, so what we are trying to do is, so we are trying to extract a data from the first row. So in a first row, so people are having like a sepal length, sepal width, petal length, and petal width. So these are the values which we have: sepal length, sepal width, petal length, petal width. Now we are trying to call a data. So whatever data we have created, so data dot plot dot pi, and here we are just trying to fix the size. So data, whenever we are going to call data dot plot dot pi, so it is going to take all of those data. So pi plot is very simple plot, I would say. So here basically we have 5.1, 3.5, 1.4, 2.0.2. So 5.1, 3.5, 1.4 and 0.2. So if we are going to sum this up, I can say, so it will be around this one. So 10.2 it will be. So basically the summation of this entire thing is equal to 10.2. Now, so whenever it is going to create a pi plot, so it will try to find out the percentage. So basically 5.1 divided by 10.2. So it will be 1 by 2 is equal to 0.5. So basically this sepal length is going to take 50% of the space. Now for this one, so 3.5 divided by 10.2, whatever is the value you will be able to get, so that much of percentage will be taken by sepal width. Then petal length, petal width, so whatever data you have, so pie chart is going to take that much of a space based on the magnitude or based on the values, as you can see. So this is called as a pie chart, a pie plot, I can say. So here what we are trying to do is, so we are trying to call a data frame, we are trying to call a head of 3. So first 3 column, first 3, I can say, row we are trying to extract. We are trying to call transpose over here. So in that way, it will try to rotate this entire data set. So whatever is the row, now it will be a column and column will be a row, vice versa. So here, if I'm going to execute it, so this is the data that you will be able to get. Now our row has converted into a column, column has converted into a rows. I'm trying to call like a data frame dot plot dot py. I'm just trying to pass like subplot is equal to true. So I'm saying that, okay, fine. So just try to implement these things into subplots. So means for one particular row, so for one particular row, one particular column, I can say, so create one pie chart and figure size equal to 20 cos 20. So here you will be able to find out that for this 0th column, it has plotted one graph. For first column, it has plotted another graph. For second column, so it has plotted another graph. So this is again the way by which we are just trying to plot it, as you can see over here. Now again, so we are trying to call the same thing, subplot is equal to 2, figure size equal to this one. Font size, we are trying to give it as a 26. So I can change the font size, like last time font size was very small. Now this time font size is big, and auto packed we can set over here. So auto packed means, so last time auto packed, so it will try to give you the percentage of occurrences. Last time it was not showing you any percentage occurrences. We are trying to say that, so till 2 decimal point, try to show me these percentages basically. So till 2 decimal points, it is trying to show you all of those percentages. So this is what you will be able to do in case of a pie plot, I can say. So we are trying to call like a 0.1 into 4. So basically 0.1, 0.1, 0.1. We are trying to create a series. We are trying to give our indexes to that. We are trying to call these things. And if we are going to call these things, so like we just have basically a 4 data set, a 40% data set that we are trying to cover. So it is trying to plot this kind of a pie plot. Again, the another kind of a plot which is a useful plot which is available is like a KD plot. So we are trying to call a scatter matrices over here from the pandas plotting, and then inside this scatter matrices we are trying to pass this entire data frame. We are trying to set that figure size. We are trying to pass time is equal to KD, color is equal to blue, and then we are trying to call plot.show. So if we are going to call these things, so what will happen in this case is, so it is going to show each and every data set versus each and every data set. So suppose I don't have to plot each and everything separately. What I want is, so I want a comparison at the same point of a time. So I want each and every row or column comparison with each and every one, I can say. So suppose if I wanted to compare sepal length with petal width, or maybe petal length, or sepal width, or sepal length, I will be able to compare it over here. So to do that, you're just supposed to call this a scatter matrices, and it is going to plot data in form of a matrices. So each and every data set you will be able to get over here itself, and you will be able to understand that, okay, so how one is going to vary based on the others variations, and you will be able to plot all of those things. So this is called as a KD. So KD wise, so whatever it is trying to print and plot into a diagonal. So basically, so if I'll talk about this one, so this is the comparison of the data with the data itself. So sepal length with sepal length itself. This is the comparison basically with the sepal width of the sepal width itself. So basically it is going to show you the distribution of the data. This is what is the meaning of the KD is. So how your data set is been distributed basically. So if data set is going to form a bell shape of curve, in that case, the data set is normally distributed. Otherwise, data set is not normally distributed. So KD plot always try to always try to talk about, I can say, or it always try to give you insights about the distribution and nothing else. So anyone who is having any doubts, please go for the questions. After that, we'll wrap up this chapter. Okay, we have so much to discuss a little bit.
Yeah. Sudhanshu, can you explain what is an axis when we are trying to plot any type of graph?
Which one?
Axis.
Which axis?
In one of the graphs, not sure which one, but in one of the graphs you mentioned axis is equal to 1, axis AX equal to AX.
Yeah, here I have mentioned, right?
Right.
Yeah, so basically I'm trying to accommodate two graphs all together. So here I've plotted one graph. I have stored these things into one variable. If it is confusing you, then you can try to take as my name, right? So I've created one graph. I have stored that one graph into one variable, right? And then so whenever I'm trying to plot a graph, basically another graph. So I wanted to accommodate these two graphs all together. So I have basically plotted one graph and then axis is equal to old variable I'm trying to keep. So in this way, both the graphs I will be able to see into a same plane. So two graphs I'm trying to. Sorry, axis is common, right? So axis means whatever data we have over here, right? Just try to put this data over here on this axis, on its axis. Simple.
Okay, so Ganshu, next question is about the pie graph which you have shown. So there you've used a parameter subplot. So if you use subplot equal to false, what we will get?
Error. Yeah.
Plot instead of subplots equal to true, use subplots equal to false.
Okay. I'm just looking for its default value. Error. I told you, right?
What is the y parameter that it's
asking for?
Yeah. Yeah, what is the
y parameter that it's asking for instead of when you put subplots equal to false?
So basically, subplot is equal to false whenever you are going to put, and you have taken a data which is having a multiple columns, right? If this column is equal to 1, in that case, you're not supposed to give anything. Without even giving a subplot, it will be able to print it, like we have done over here. But if you have a multiple column, so in that case, for sure, it will look for subplot is equal to true. So whether you are not giving subplot or you are giving subplot is equal to false, both the things are same, and in that case, it is going to give you error, nothing else. Fine.
Figure size will always be 2020 or 1010 like that.
You can put any kind of figure size. That is not a problem. Yeah. Okay. So any other question? Anyone?
Yes, Sudhanshu. Sudhanshu, if you scroll down to the last pair plot thing, you just said that if we receive a bell curve, then our graph is normally distributed. What is the definition of normal here?
So normal distribution means we are going to talk about normal distribution and normal distribution in your stats class in very detail with formula and everything.
The kind of distribution.
Kind of distribution. So normal distribution as of now simply means the kind of a distribution which forms a proper bell curve.
Okay. I thought normal is like just normal, the way we say normal.
Normal distribution is basically a term in statistics.
Okay.
Hanshu, what is KD means?
Normal distribution.
KD also normal distribution?
No, KD itself is a normal distribution. KD is called as a normal distribution. It's not, so in case of a graph plot, so meaning of KD itself is a normal distribution, basically. So distribution, I can say, not a normal distribution, precisely distribution. So it always try to show you the distribution of your data set. That's it.
Kernel density estimation.
Sorry?
Kernel density estimation, something.
Yeah, kernel density actually. So that is basically a normal distribution itself. Okay, so moving ahead, basically here, so we are trying to call same old data that we have used, and style wise, so we are going to give R hyphen hyphen. So basically R is a color, hyphen hyphen is just a style. So the way it should be able to plot it. Label is equal to series we have given. Legend is equal to true, means this is the legend, means notations. So again, I'm just trying to showcase you some of the fancy stuff over here, nothing else. So here we are trying to keep legend is equal to false. So legend equals to false means it will not try to give you that box which defines the meaning of the graph, as you can see. So if I'm going to make legend is equal to true over here, so you will be able to find out a legend in this particular place. As you can see, sepal and sepal width, pedal and pedal width, and all those things. Now, so here we are trying to call a simple data set. I can say we are trying to drop sepal length and pedal width over here. Now, so after dropping these things, so we are trying to plot one graph inside the another graph. So again, it's the same old thing, same old approach that we have mentioned. mentioned. Now again, so if we are going to call xplot and then figure size equal to this one, x compact is equal to true. So in this case, so compact wise, so just a representation, I can say a Windows wise representation in which it is going to show you the data. Now we can try to call data frame dot plot. We are going to keep subplot is equal to true. So if we are going to keep subplot is equal to true, so for sepal and sepal width, petal and petal width, so it is going to create a different boxes itself. So this is what you will be able to get if you are going to keep your subplot is equal to true. Now here, so we are trying to keep our subplot is equal to true and share x is equal to false. So we are saying that, okay, fine, I don't want to share my x-axis, and layout is equal to 2 cross 3. So basically 2 cross 3 is nothing but 6 boxes it can create. So 2 row 3 column. This is the meaning of this layout. So it has created 2 row 3 column. We basically had 4 different kind of a column. So it has plotted all those things in the different boxes. So in this way you will be able to control these things, and we are just trying to call like a tight layout, so that is completely fine. So you will be able to get this kind of a data. So likewise, so you will be able to create so many different kind of graphs. So it's possible like a bar plot, scatter plot, KD plot, scatter matrices plot that we have discussed, a histogram that we have discussed, a pie plot that we have discussed, area plot that we have discussed. So these are the different varieties of the graph in general people are using across the entire data science industry, I can say. So you will be just able to use it, and you will be able to like build plot, and you will be able to perform all those analysis on top of that. Now the next library that we are going to talk about is basically a plotly and couplings. So whatever we have discussed so far, so forth. So that was a very simple and plain graph. We were trying to give a data set, and based on that, it is trying to show me the representations. It was very plain and simple. Now, so we will be able to create a fancy kind of a graph as well. As you can see, I'm trying to create this fancy kind of a graph. So you will be able to do the same kind of a things. So even libraries are available, and you're not supposed to write a much line of a code. A same 1-2 line of a code is going to work fine for you, and you will be able to perform all of those operations which we are talking about as of now. So everything you will be able to do basically. So as you can see, so we are trying to plot a lots of a 3D kind of a graph. So you will be able to do that. You will be able to get into single scatter dots at any point of time. So let's try to understand that how you will be able to use this library and how you will be able to plot data based on this library. So by default, matplotlib and seaborn will be available inside your Anaconda distribution, but plotly and couplings will not be available inside your Anaconda distribution by default. So first of all, you will have to install it. So there are multiple ways to install libraries inside your environment. So one way I would like to highlight over here is Anaconda prompt. So you can just try to search for the Anaconda prompt, and then you can go over here and then you can do pip install. And maybe suppose if I'm trying to install plotly, so I can just try to type a pip install plotly. I will be able to install it. So pip is basically, it's a kind of a repository. So it will try to find this particular plotly library. It will try to install it inside your local system. If you are like don't have a sudo permission, if you don't have a super user permission, maybe you can ask your admin, or you can try to fire sudo pip install plotly. But yes, in general, it will work. I would say it will be able to install it, and you will be able to use it. The other way is to go inside basically Anaconda prompt itself, I can say. So the GUI screen, and from there also you will be able to find out, you will be able to install. The third way I would like to show over here is this one. So by using like a pip install plotly and pip install couplings, by giving a negation symbol in a beginning, you will be able to install any of these libraries inside your existing Anaconda environment. So these are the way by which you will be able to install a new libraries which is not available inside your current packages that you are trying to use. So far, so forth. So in my case, it is trying to showcase that requirement already satisfied. So I have already installed it so many times, basically. So here now I'm going to import all of those libraries one by one. So here I'm trying to import a same old libraries. Now here, so I'm trying to call plotly offline, because plotly libraries are available in an offline mode as well as it is available into online mode. So I'm trying to call plotly offline, and again, so Plotly tools and all those things, I'm trying to use Cufflinks is basically a supportive library for the Plotly. So Cufflinks always try to provide a configuration at any point of a time. And inside this one, so we are going to understand and we are going to study this line plot, scatter plot, bar plot, blocks plot, spread plot, ratio plot, and all those things. Whatever things you are able to see over here, so we are going to talk about these things. Again, here I'm just trying to show you a version. Here, so I'm trying to call some data frame here, nothing else. So just remove this thing, these things are not required. Now, so here what I'm trying to do is, so I'm trying to call like a Python dot offline init notebook mode connected is equal to true. So here I'm trying to connect with the offline mode, basically. So because I'll show you, so these things are available even with the online portal, and even you can go to the online portal, you will be able to change the data set and you will be able to perform all of those operations. So here I'm going to going offline. Here we have a data frame. We have created a random data set, I can say, of a dimension 100 cross 3, so 100 rows, 3 columns. And here we have a data frame which we have created. So if I'll try to show you this data frame, this is how it looks like. So I'm just trying to create some dummy data set so that I will be able to plot it. So here is the data that we have already created in this particular place. Now, last time, if you remember, in case of a matplotlib, so you were trying to call data frame.plot. The only differences you will be able to find out over here is data frame.iplot. That's it. So here I'm trying to mention data frame.iplot, just I. There is only one changes. There is I. If I'm going to execute it, so you will be able to get this graph, and this graph is much more, I can say, powerful than the previous graph. So whenever you will try to hover your mouse on top of the graph, so it is going to show you a value. That is one thing. Apart from that, so there are many features you will be able to receive with the help of this Plotly. So this is much more interactive, I can say. So there are lots of features which people have given over here. As you can see, for zoom in. So if you wanted to zoom in this graph, if you wanted to zoom out this graph, you will be able to do that. If you wanted to see some of the intersection of this graph, you can see that as well. If you wanted to take a snapshot, you can do that as well. So lots and lots of things you will be able to do. And again, so like lots of feature people have given. Now, so there is an option called as export to Plotly. Now, if I'm going to click on this option, so it is going to open up the same data with the same graph into my online dashboard, into my online portal, I can say. So as you can see, so it will try to take me to the HTTPS URL of Plotly. And here it is trying to take me to the HTTPS URL. And here you are able to see that it's exactly same graph I'm able to see over here, but it's on a HTTPS. Now, if I'm going to make some changes over here, suppose if I wanted to do a real-time data changes, if I wanted to observe that how my data set is going to behave, if I'm going to change one thing, so with respect to one thing, how my other data set is going to behave, I will be able to see it then and there without writing any single line of a code. So I'm just changing my data set over here and it is trying to change my behavior. Not only that, so apart from this, you will be able to see many other features as well. So suppose if I wanted to plot a different kind of a graph for a different column. Suppose for the column A, if I'm looking for some other graph, suppose for column A, I'm looking for bar plot. Suppose for a column B, so I'm looking for basically maybe a scatter plot, let's suppose. And for column C, so I'm looking for maybe area plot, let's suppose. Yeah. So as you can see, so I'm able to do each and everything without writing even a single line of a code. This is how easy it is. You will be able to add any kind of a column. You will be able to manipulate any kind of a data set. You will be able to do whatever you want. And you will be able to change your x-axis to y-axis to x-axis, basically, just by doing those things. I can say you will be able to change a color. You will be able to change vertical, horizontal, like we have seen bar, H and bar. So vertical and horizontal. So just by using this option, so you will be able to play with these things, and then you will be able to perform almost all the operations which you can imagine at any point of a time, starting from your color to access to everything. Now, not only that, so you will be able to store, you will be able to save all those library, all those things. So you just have to log in over here. It's free as of now. So some of the services they are trying to sell, but yeah, almost most of the services are free, at least till now. So you will be able to annotate, you will be able to choose a style, text, images, you will be able to import or export as a images or as a HTML file. So every possible things in terms of beautification, you will be able to do it. And again, this graph is much more interactive as compared to, I can say, Matplotlib. So many options are available, many things are possible over here. So if you are using these things, this graph, so you will be able to perform so many examples or so many operations. And very less people are using this Plotly and couplings, because recently people have developed this library. So maybe in a near future, so we are going to use this kind of a library extensively. But yes, as of now, because people are not aware about it, so people are not using it. But personally, I like this Plotly and couplings library. And wherever I need this kind of a graph, so for sure, I generally use it. So yeah, anyone who is having any concern or questions, please go for your questions.
Actually, my question is regarding for if we wanted to be like design the like data model as well in Plotly library and whatever the library.
I'm not able to understand you actually.
Actually, my question is regarding in a ClickView and ClickSense tool. Basically, we are
sorry. Your question is regarding
in a like we wanted to design their data model basically.
Yes, yeah.
Connection between the different tables is there. We want to implement the connection between it. Okay.
Yes.
So
yes.
It is possible in Python language. By using Python language, we can design it.
Basically, you will have to write a code. Basically, you're talking about a ClickView, right? So yes, I know that in ClickView, so you will just drag and drop a columns. You will be able to establish the relationship.
It's not
you will be able to do
drag and drop only.
Modeling. You will be able to, you will be able to do a modeling, basically data modeling just by doing a drag and drop, right? Some like fancy things, fancy stuff is there, because yeah, I have done lots of dashboarding even into ClickView, Tableau, as well as Power BI.
Okay.
Right. So I have idea about that, and even so, like I have deployed these things on a ClickView cloud itself, private cloud that they used to give, right? So I have a quite fair idea about your ClickView in which you are working as of now. So basically, what I think over there is it's just a drag and drop. By loading a data set, exporting the data set, you will be able to build a data modeling. In Python, you will just have to write a code, basically, some 1 or 2 line of code. Now, so even in ClickView or even in Tableau or even in Power BI, so whenever you're trying to do a data modeling, so before that you should know a relationship.
Yes.
Right. So if you know the relationship, and then if you're trying to do a drag and drop, and by that if you're trying to do a modeling, so if I know the relationship, I just have to write 1 or 2 line of code, right, in Python. Okay. And again, so same kind of a data modeling, I will be able to do it. So like I said, so in general, data scientists don't need those kind of tools, I would say.
Yes.
So for data scientists, because data scientist is not the one who will try to work on the predefined structure or something like that. They will have to derive that. They will have to derive their own kind of a modeling. And if I can derive my own kind of modeling, so for sure I will be able to write a code for that, 1 or 2 line of code, right? So that's the reason it's generally been designed for all the dashboarding tool has been designed for like a data analyst people who just try to publish our reports based on some of the I can say configured informations, and yeah, this is what you can do into any of this dashboarding tool.
Okay, in a Plot library, we can do it the same thing for data modeling related. This one, the library you are talking about, now the previously Plotly.
No, it's a Plotly basically. So in Plotly, or any of this Matplotlib, Plotly, coupling, Seaborn or Bokeh. So these libraries is not been designed for a data modeling. Okay. They don't understand a data insights, or they don't do a data mapping. So you will have to write a code for that, and based on that, they are going to give you the result. So this is basically a complete Python API based libraries, I can say.
Okay. Hi, Sudhanshu.
Yeah.
I have one question. Like, suppose I am generating some log from one embedded system which I deployed in the cloud, like my gateway. So over there, syslog is generating, but there is some log level will be there, like error or info or different various kind of log level. So depending on error log level, I want to segregate the data, and depending on that field, I want to create some plot, like how much, what will be the
that is fine, right? So plot is, yeah, that is fine. So plot is nothing but I can say just a X and Y values. So you just have to decide that which versus which data you are looking for. Basically, maybe a number of the log that you are generating versus the error file that you're generating. So you're looking for data, that kind of a data. You can do that. You just have to pick 2 columns, I can say.
Okay, so
Yeah.
how means I have to choose that field, like means like in my suppose I am while logs are coming, I already generating some CSV file in a proper format that this is the field of error log, and I want to choose them to generate some means plot, like this much percentage of error log I am generating, and depending on that I want to write some algorithm fix those issues like in future.
Yeah, so basically you have to decide in that case that which versus which data you are looking for, right? So no one else is going to tell you because you are the stakeholder for those things, right? So graph means, so it is just going to give you insights, right? Okay, fine. So maybe you can try to plot this log information based on the days, weekly basis, right?
Yes.
So last
Yes.
week, so we have, so maybe on a x-axis, so you can try to pick our days, basically like weekdays, right? So maybe
Yes.
on every Monday or every Saturday, Sunday, you are getting a huge log. So there could be some problem
Yes.
with the system, maybe because of overload, because of something, right?
Yes.
So you are getting a lot of error log. So maybe you can try to plot this kind of a graph, days versus log, or maybe
Yes.
log versus error log. So
Yes.
it will be you who has to decide. No one else is going to decide on behalf of you, right?
Okay.
And all those things are possible. If you're going to pick x-axis, y-axis, just plot it.
Sudhanshu,
Yeah.
this PLT dot plot d of and df dot plot both are same, na?
Yes, yeah, both are same actually.
So we can do different way of.
Yes, yeah.
plotting,
So that's the reasons I have mentioned. Yeah, this is basically like from the matplotlib itself.
Yeah. Okay.
So
Thank you.
Sudhanshu, we don't have this. We don't have this Oracle connection for this plotly, right? I mean, as per the discussion, as
No,
it
connectivities are not available in general into a graphs. So don't try to misunderstand this as a dashboarding tool. Graph is not a dashboarding tool. I never said that you can use a graph for the dashboarding purpose to generate a reports. I always say that graph has been used to generate insights. There is a difference, basically, right? So graph is not a dashboarding tool. You will not be able to connect with any of the databases. So you can use a Python program to connect basically to your databases. You can pull the data, plot it, and check the insights and check all those details like, okay, fine. So how my data set is varying. And based on that, you will be able to take some decision. So basically for the decision making, not the end decision making, because the dashboard that we used to create, so that has been overseen by your management. And they used to make a decision. End user used to see that. But basically here we are trying to plot a graph so that we as a data scientist will be able to understand something, because we don't know what we are looking for at the end, basically, right?
Okay.
So don't get confused between a dashboarding tool and a graph. Both are different, and both has been used by a different roles and responsibility with the different people.
But we have the access to modify the data to see the differences, right? As you have shown the column and row values you have changed, so we have the access for that, right?
You can do anything, right? So if you have a data set, yeah, for sure. If you're the owner of the data, you can do anything, whatever you want.
Okay, got it. And one more thing, in the previous, before starting this chapter, we have seen the legend, right? So when we have seen
Legend is nothing but this one.
Yeah, that one. So it is coming in different positions. Sometime it is coming.
Yeah, you can pick the position as well. So basically for legend, so you will be able to give 8 possible position which legend takes.
Okay.
So you can maybe keep into a middle, this side, then bottom side, right and left, then middle, and then outside.
Okay. And whenever it is coming at some other space, is it checking for the space available in that graph?
It try to adjust by itself. Yeah. Otherwise, you can give the position. So if you are going to give a position, in that case, it is not going to check for the available space.
Okay. But in some of the graphs, even if we don't give the legend, it is coming. It looks like
yeah, by default system try to give a legend actually.
Okay.
So even if legend is equal to false, so you will be able to get the legend.
Okay, thanks.
Yeah.
Please go to line number 8.
Sudhanshu.
Yeah.
So Sudhanshu, can we
Where line number 8 by the way?
Sudhanshu, can we export these graphs into Tableau or Power BI tools, and we can
No, you will not be able to export these things. You will be able to export these things into your maybe doc file or maybe Excel sheet or maybe into HTML. But you will not be able to, because Tableau always creates a different kind of file system. Power BI creates a different kind of file system, and ClickView creates a different kind of file system. So this is not compatible with that file system. You will be able to export or import it as a JPG or PNG, means the image format.
Then in a real time, how we analyze these graphs into the any other tool?
No, why do you need this graph to be in tool? Basically, we are not using this graph for the dashboarding purpose, right? I think I have made this thing clear many times. Right? Graph is having a different purposes. Dashboarding tool is having a different purposes. Basically, graph you are going to use to understand the insights as a data scientist, as a data analyst. So you are going to use dashboarding tool. So why do you need this graph to be available into other tools?
Okay, okay. Data analysis purpose only we can use.
Yeah. So data analyst is a different job and roles itself. Basically, where they used to create just a dashboarding things day in day out. Right? They will keep on creating a different reports. Basically, they will work on a reporting side. So as a data scientist, do you want to work in a reporting side? No, right?
No.
Exactly.
In a real time also, we won't work on these graphs, right?
No. So basically, like you work on this graph. This is a Python graph that you're trying to create to understand the insights. It will help you as a data scientist, right? To understand the data.
Understand the data and the like business purpose also we can understand how it will be representation everything.
Exactly. Yes.
Thank you so much.
Yeah. Moving ahead. So here we are trying to call basically like a I plot, and inside this I plot, so we are trying to call like a column A, column B. So same scatter plot kind of things we are trying to call. Mode is equal to marker, size is equal to 25. So we are just trying to give marker like a round kind of a shape, and then size is equal to 25. So yes, it's completely fine. So size you can increase or decrease, and based on the size, so it is going to give you this kind of a data. Again, you can hover your mouse, you will be able to get a values. Again, you can click on this export to plotly.ly, and you will be able to export this data. All those things are possible, I can say. Now here, so I'm trying to call again the same old titanium data set. Nothing fancy, I can say, from the same Seaborn libraries. Again, I'm trying to call titanium.iplot. So everywhere, the only changes which I have done over here is iplot. That's it. So from plot to iplot, that's it. Kind is equal to bar, so I'm trying to do a bar plot. So on a x-axis, so I'm trying to represent a 6 column. On a y-axis, so I'm trying to represent a survived column, as you can see. So inside the 6 column, so basically we have a male and female, and then on survive column, so it is trying to tell me that, okay, fine, so how many male was able to survive and how many female was able to survive. So title I have given as survived. So yes, this is the title that you will be able to see over here, and X title is equal to this one, and Y title is equal to this one. So as simple as that. So we are like able to plot a bar plot over here in a beautiful way, and if you can hover your mouse on top of this one, and then you will be able to get the data. Again, you can export these things into HTML pages, and then you can change the data. You can try to manipulate the values even at that point of a time. Now here, so I'm trying to call Titanic, and again I'm trying to call a 6 column over here. Again, I'm trying to call a value underscore count. So value underscore count basically try to give you a group by count operation. So it is trying to tell me that, okay, so in male, how many data set was there? In female, how many data set was there? So these are the things that you will be able to observe. Now, so here you will be able to find out some of the themes as well. Theme means just a background, basically the representation. So you will be able to get this kind of a theme. So if you have, I'm just trying to list down all those themes in this place. So if I'm trying to give maybe a pearl theme, as of now I'm using white theme. So you will be able to see that the background has changed. So if you're not able to see a significant differences, maybe I can try to pick something else over here. And as you can see, the theme, the entire background has changed. Now, previously it was a white kind of a things. Now it has changed to black. So like I said, CF, couplings is been used for a configuration of the plotly. So here I'm just trying to change the configuration to Henning gains or something like that. And kind of a graph I'm trying to plot as a bar. Bar mode is equal to stack. So one after another, I can say, and bar graph is equal to 0.5. So I'm just trying to set the thickness of that particular graph. That's it over here. So the same old approach that we have applied last time. Bar mode is equal to stack, same thing. Now, so here I'm trying to use same thing. I would say data frame.iplot. So instead of using a bar, I'm using a bar H. So bar horizontal. So it is going to give you a same kind of a graph that we have plotted last time. iPlot means simple. It's a line plot that you will be able to receive. Now, so here I'm trying to call iPlot kind is equal to area. So basically I'm trying to do an area plot. Same thing we have done even in our matplotlib, and fill is equal to true. So it will try to plot all those graphs and it will try to fill each and everything over there. That's it. Now here I'm just trying to create a data frame, and basically I'm trying to create a data frame over here, and based on the data frame, So I'm trying to call a iPlot. So iPlot, and then inside that, so I'm trying to call a surface. Means kind is equal to surface. So kind is equal to surface whenever I say, so it will be able to like create a 3D kind of a plot. As you can see, so I have basically a 3-axis over here. I have basically a 3-column, X column, Y column, and Z column. So it will try to plot this graph into a 3D coordinate, and it will try to create like a surface. So it's a surface graph that I'm able to plot it in this particular plane. Okay, I just have to increase the size. Yeah, so this is the surface graph that I'm able to plot as of now. Now, so the other things that I'm trying to do is, so here I'm trying to generate a data. So this is just for the data generation. So I'm just trying to take a default data set, nothing else. You can take your own data set, and then you can try to call the graph. So here I have created my own data frame, as you can see, and I'm trying to call a surface graph. So based on the dimension and based on the tendencies of the data, so it is going to take that shape automatically, I can say. So here I'm trying to generate a sinusoidal wave kind of a data, I can say. Again, I'm trying to do the same thing. I'm trying to call a surface, and if I'm going to execute it, so you will be able to find out that it will end up generating a sinusoidal wave. So basically, sinusoidal wave we are trying to generate in this particular place. So how beautiful it is, just you can look into that. So again, 3D kind of a graph I'm able to generate. So you're just supposed to call iPlot kind is equal to surface, and then put your data set. That's it. And all those 3 coordinates you'll have to give. Now here, so we are trying to do a scatter plot, but as you can see over here, so we are trying to call a scatter 3D. So here I'm trying to call my own data set. So here I'm trying to generate some of the default data set. You can choose your own data set. There won't be any issue. You can choose your own data frame where you have like a 3 columns, and it is going to give you the same thing. So here I'm trying to pick just a kind is equal to 3D, and then so I'm trying to call X is equal to X, Y is equal to Y, Z is equal to Z, and I'm able to get a scatter plot into a 3D. So you can try out these things with your own data set. That will be better, and you will be able to get this kind of a graph. Now, so here I'm trying to do one thing like I'm trying to select like a AB column. I'm trying to call like a AB, and the spread is equal to the kind is equal to spread. So if I'm going to create a spread over here, so it is going to show me some of the magnitude as well with the filled graph. So again, it's another kind of a graph. Here I'm trying to call histogram. So same old histogram, meaning is again same, I can say. And here I'm able to create the histogram graph, as you can see. Now here, so bubble 3D. So if you wanted to do a bubble 3D, last time we have done a scatter 3D. If you wanted to do this bubble kind of a things, and if you wanted to plot a 3D graph, so you will be able to plot the 3D graph. So here you're just supposed to make kind is equal to bubble 3D. This is the data set which I'm trying to generate from the library itself. You can take your own data set. It's always advisable for you to take your own data set, I would say. Now here, so we are trying to generate a heat map, I would say. So here, if I'm going to show you this data, and if I'm going to show you the data that I have generated over here, so you will be able to correlate in this particular place. So here, this is the data set which I have generated, and as you can see, so wherever I'm going to hold a mouse, basically, so it is going to give me X value, Y value, and Z value. Z value is nothing but it's a representation over here. So basically it's a heat map. So it is just trying to give you a color scale. And basically it is going to tell you that when X value is 4, Y value is 6, then Z was this one. So this is what it's going to represent, I can say. So when X value is 0, Y value is 0, then this was the Z value. So you will be able to find over here, basically. So when X is equal to 0, Y is equal to 0, so what is the values that you will be able to get? So this is the data that you will be able to receive, and just based on X coordinate, Y coordinate, and Z coordinate. So we are trying to draw this heat map, nothing else, I would say. So anyone who is having any question, please go for that. Yeah. Heat map.
Yes, Sudhanshu, as you said that these graphs will be just for us as a data scientist.
Yes. Yeah.
So I understand the heat map thing, but the above graph which you shown, like very, very fancy ones. So what is the significance of those? Because personally,
so suppose I have like a X-axis, Y-axis, and Z-axis, right? I basically try to understand the shape of the data, right? Because if it is showing a cosine wave or sinusoidal wave or maybe hypertangent wave, right? Some kind of a things, or some kind of a 3D pattern if it is going to showcase. So basically it will help me out to visualize a data into a better way, how data is behaving, right? If I will be able to see a data in my surroundings, basically to a 3D, so it always gives me a better insights, right? That's the reason. So that's the significance of using those, I can say, 3D kind of a graph that we have used. So here, these graphs, yeah. So these graphs. So basically, you can call your iris data set, you can call any of the data set, you can select 3 columns, and then you will be able to plot this graph, right? So you will be able to see that, okay, fine, this is how my data is behaving. And based on that, you will be able to take a decision whether you will leave it or you will accept it.
Yeah, and when you will cover those stats section, will you be covering the cosine wave, tangent wave? Because I think it is difficult for me at the moment to understand.
Okay, fine. I will be covering few of the mathematical topics, but yeah, not on that low level.
Okay.
Sine or cosine. Yeah, I'll talking about some differential calculus for sure.
Okay. Okay, and reading of those graph is on us, that how do we read it, right?
I will talk about like a graph things. Will keep on talking about these things so many times, even till your deployment and everything, right? So yeah, it depends. Reading of the graph. So even in EDA, if you see 10 example of EDA, so many graphs are there, and their graphs are much more complex. And data set that I have taken is much more complex. So there again, I will try to give you the insights, because the whole idea behind EDA is to give you the insights. And 10 complex application we have already uploaded in your dashboard, and we are going to talk about that, so that you will be able to brush up each and everything from the Python, from the graph, from the insights, everything.
Okay.
So
yeah, next question.
Heat map, in heat map, when we need to use?
Heat map is basically has been used again into a comparative study, I can say. So here you will be able to see that when value of x is this one, value of y is this one, then this is the z value, right? So basically it is trying to represent. So as you can see in this area, so in this area, as you will be able to observe that heat map always use a color encoding, right? So they are the different color. Again, if you'll see, there are different values. You will be able to find out 20, 0, so 20, 40. So this is minus 20 actually. So basically it is trying to represent whenever I'm trying to hold a mouse over here. So basically it is trying to tell me that, okay, so whatever data you have in y19 and x0 coordinate, so the value of that data is minus 24. So can I say that minus 24 is falling below this?
Yes.
Yeah, below minus 20, this area, right? So it's trying to represent that particular one, this area. Can I say that?
Yes.
This will fall basically in this area. That's the reason that it's trying to represent these things by a red one. So if I have to do a study based on the geography, maybe latitude, longitude, I can say based on the sample distribution and dispersion. So in those kind of a relative study or comparative study, so yeah, I can use that heat map. So yes, you are going to use it even in your EDAs and in your project part.
Okay, so it's comparing the x and y to the right side, this column.
So basically it is trying to take out the value of x, and so basically it's trying to give you the value of z. Based on the value of z, it's trying to give the color encoding.
Okay.
So suppose if I'm going to hover a mouse, right? What is the value of z?
It's 3.5.
3.5. Okay, I'll show you a very clear picture now. So I'm just going to take these things into some of the variables. So suppose d is equal to this one, and I'm going to assign this as a d. Okay, and then I'm going to show you d over here. Now tell me, what is the value of x0 and y0?
It's 12.0.
Yeah, so x0, y0 is equal to 12.0, right? 12.0, agree?
Okay.
12.0 here, if I'm going to hover a mouse, x0, y0 is 12.0, right? So what is the color coding it has given? So can I say that 12 will be vary in between somewhere over here?
No, x and 0, it's coming at 0, right?
Which one?
That point?
No, just tell me one thing. What is a value of x0 and y0?
It's 12.0.
12.0, right? If I'm going to hold a mouse, what is the value of z? Value is 12.0, right?
Yes.
For 0, 0 matrices, value is equal to 12, right? Now, so if you will look into this scale, so can I say that your 12 will come somewhere this is 0. Are you able to see it, or else shall I change the like a background?
That's visible.
Visible, right?
Yes, yes.
0, 20 and all those things?
Yes, yes.
Yeah. So basically, can I say that 12 will come somewhere over here?
Yeah, exactly.
So this color, so this is, it is able to get this color. Making sense?
Yes.
So basically it is just trying to give you the relative study that, okay, fine, so this is my scale. Now if this versus this data is varying, then what will be the color, or what will be the like a representation of the data you will be able to get.
Individually we need to study like this, or how we can
Sorry?
Individually we need to study each cell, or how we can
Yeah, so you will have to study in that way. So suppose if I'll ask you one question, right? I'll ask you one very basic question that, okay, so suppose this is representing a latitude longitude, right? X-axis latitude, this axis longitude. It is representing starting from 0 to 19, starting from 0 to 19. I'll ask you a very basic question over here that, okay, fine, tell me in between what latitude longitude to what latitude longitude temperature was in minus.
Okay, it's below.
In between what to what latitude longitude temperature was in minus. How you are going to answer it?
I mean the dark color, right? The bottom.
So can I say that the color for this minus is this one?
Right.
Yes, correct.
Color for this one is minus one is minus is red, right? So can I say that for variations in between 18 in terms of x latitude and in terms of this one, so from 8 to 19. So this is the red. Again, this is the red. This region is red, right? So we are supposed to spotify each and everything. Now, if I'll tell you, if I'll ask you again another question, that where, in which region, from which latitude longitude to which latitude longitude, there is a temperature which is beyond beyond like acceptable scale. So can I say that we are talking about this blue one, right? Blue degree Celsius, 60 degrees Celsius is too high, right? So can I say that the temperature between this latitude and this longitude, right? So basically between this latitude and this latitude, the temperature was too high. So basically a Y ranging from maybe 8 to 19.
And X ranging 16.
And X ranging from 16. Basically 16. So in between this range, so you have excessive temperature. Can I say that?
Yes.
So to get this kind of insight, so basically like I can derive maybe 100 different kind of insights out of the data, basically.
Yes.
So graph is just the things which is going to help me out. And the same thing you will be able to receive and observe in ADA.
Yes.
Yeah?
Yeah.
So this is how you should read out the graphs. So various different graphs you can read out in a different way. Okay?
So Sudhanshu, one quick question, like you have used basically cufflinks to get this data, right? This dummy data. So can we use Plotly itself to create this dummy data? Do we have any?
Yeah, so almost every library provides a dummy data set, and why you're looking for the dummy data set, just call any of the data frame, try to plot it. You just need x-axis, y-axis, z-axis, right?
Yeah, I got it. I'm just wondering whether it's possible with Plotly or
that
not.
That is completely fine. Just try to use your own data set. You just need 3 data set, 3 label, like a 3 column, x, y, z. That's it.
Yeah, hi, Sudhanshu.
Yeah, go ahead.
Just you shown the heat map. We have claims data for 1 year.
Okay.
How in our web application, how do we represent that heat map into our web application or some representation stuff like that?
So depends upon your insights, right? What kind of insights, what is your understanding about the data? So if you can show me your data set and if you can tell me that, okay, fine, so this is your understanding, based on that, anyone can tell you, right? Just by saying that, okay, fine, so this is the data set that I have. So what is the kind of a heat map that I will be able to plot? I think no one will be able to answer in this entire.
No. Actually, my point is that how would I will be able to show it in a web representation, that heat map?
Web representation into a heat map. So
yes,
are you talking about a batch? Basically, are you talking about the batch load or like a real time?
Real time. Let's suppose we have.
You're understanding my point, right? Why I'm asking this question?
Yes, because the data would be in huge amount.
Okay, so you want, if you are looking for something into a web application, right? The best library which I can suggest you is D3JS. This is one of the best libraries. The best means you will not be able to find much more beautiful libraries beyond this one, D3JS. And again, it's too powerful, D3JS. Again, we are using these things. basically in most of our application to generate insights and to do all those things into a real time basically. Again, if you have a batch mode, then you can go ahead with anything and they can just keep on pushing those graphs. But yeah, if you're something looking for something into a real time, go for this D3JS. It's very powerful. It's very smooth. Again, lightweighted. I will say libraries you will be able to get, and you will be able to plot any kind of graph. See, the graph which you can't even imagine, so far so forth. Yeah.
So at the same time, we could use Plotly in
Plotly basically it's not been used for the production purpose. I would say if you have a real-time data sets, because Plotly means what? Plotly means you will try to run something into an intermediate server, and then you will keep on pushing in your web pages, right? Okay. But here, so what will happen is, so you can connect your like a front end with a back end with the help of this JS JavaScript, and then it will be able to refresh based on the timer that you are going to set. So I will suggest you, like, if you're going ahead with the web application and if you have to plot those graphs into a real-time or mobile application, the best library will be D3JS. According to my knowledge, maybe someone else can suggest you a better libraries, but yeah, according to my experience, this is best one.
Thank you.
Yeah.
So can we use this library with Python itself?
No, it's a D3JS. Actually, it's a JavaScript. Actually, so we used to we generally use this library for a production grade graphs.
Okay.
Yeah.
Hi, Sudhanshu.
Yeah, go ahead.
At the end of the session, can I have your 5 minutes of the time? Because next week I have an interview. They given me a task to complete, and I just need a little understanding about that. It's not a data set to solve.
Fine, you can share your screen if you have.
Okay. Thanks, Sudhanshu.
Yeah.
Share my screen, right?
Yeah.
Are you able to see?
Yeah, I can see that screen.
Yeah. This is a project plan.
Okay, the lifestyle service metabolism strategy based on the personalized and the recommendation. Main duties is system training, system integration analysis, system rollout, presentation. Using your previous experience in web development and machine learning, explain how this can benefit the project. Okay.
So what is from Sudhanshu?
Okay, fine. So basically, like they have given you. So what is your total experience? May I know?
In India, I have 3 years of experience, and
in total,
4 years.
Okay, so basically, like this is something like they're just looking for how you will be able to approach to this problem, I would say, and then how you will be able to try to give this answer. So this is not a technical question, I would say. So here they have given you one simple problem statement there. So based on the personalized input, so you're supposed to generate a dietary recommendation. And again, they have included this web application as well. So in the simplest possible approach, if I would like to talk about, so they are looking for some web application development, and they are looking for some of the mobile application development where, so you are supposed to showcase, or you are supposed to project that how you are going to generate a data, how you will be able to collect the data from the users, basically. So how from the users you will be able to collect the data, and based on those data sets, so how you are going to do the recommendation. So first of all, in the stage 1 complete business understanding, so you can just how good you are with the all this input that they have given for this dietary recommendation. Then device and automated system structure. So means you are supposed to suggest them that how you are going to design automated system, basically, which can take a data input from the user, and based on that data input from the user, so it is going to recommend a particular user that, okay, so this will be your diet or that will be your diet. So in that case, you are supposed to always make sure that what are all points you are going to collect. Because if you are trying to recommend some user in terms of a dietary, so you are supposed to take their weights, you are supposed to take their what is their current diets and all those things. Basically, what is their current exercise routine, whether they have some disease or not, what is their historical medical record. So you are supposed to create a UI in such a way that it will be able to get all of those data one by one from the user, I can say. And then based on that, so you are supposed to build a machine learning model where it will be able to give a recommendation that, okay, so if this is the symptoms or this is the phenomena user is showing, then this could be the possible, I can say, a diet. So because your final goal is to give a dietary recommendation, as you have mentioned the second line. Now mobile application system implementation. So yeah, so same like the system.
Just a second. In stage 2 itself, all the machine learning pipeline will become to picture, I think then.
Yeah, so all this machine learning pipeline will come.
Okay, done. And next.
So basically data, what and all data input you are going to capture, basically. So whenever we say device and automated system structure, so how you're going to capture a data, that will be the first thing. What in all points you're going to capture, that will be the second thing. Then what you're going to do with that point and what machine learning algorithm you're going to build on top of that, that will be the last point. And then final deployment. So deployment into mobile application system implementation. So again, how you're going to design a mobile kind of application where in as smoothest possible. People who are not speaking, please go on mute. Otherwise, I'll remove.
Just mute them to them.
Yeah, it's better to remove them instead of muting them. Yeah, so basically mobile application system implementation. So in case of that, so you will have to design a UI, like how your mobile application should look like and how user will be able to insert a data through that mobile application, what in all points they are supposed to consider. So basically it's a UI designing, nothing else, nothing fancy. Now system testing, again system testing. So whether you have built a model, it's working fine or not, whether you are able to capture all the data. Yeah.
Sudhanshu, here this UL designing means it's a deployment, no?
It's not a UI designing, it's not a deployment, I would say. UI designing is simple UX. So UX and UI and deployment is different, right? Deployment
it's a map we can design, that's all.
What are the tools, Sudhanshu, for UI designing? From machine learning engineer, what they will expect?
No, it's not like you are not going to design this UI basically. So there will be some Android developer, there will be some I can say a UX UI developer, or there will be some Bootstrap developer, I can say, or there will be some iOS developer who is going to do that. They are just looking for some of the architecture, whether they are just looking for something that you are able to understand it or not. They will give you this task whole and soul, right? If you will be the owner, so they are just expecting from you that you will be able to deliver those tasks or not. They are not expecting you to design a UI. No one will expect that from data scientist, right?
Okay.
They're not going to build an Android application. That's the one thing. Second thing, system testing. So yeah, end-to-end, from the data gathering, I would say, from the model validations, from the UI validations, from end-to-end integrations, and plus the scalability, whether the solutions is scalable or not. So they are looking for that. Now, web application system implementation, same thing as a mobile application. All these things will come into picture. So it's for the web user. Then extended system scalability.
So again, is it like we are just converting to mobile application and Heroku and our platform is same thing?
Don't say Heroku in an interview.
Okay.
I just say AWS, GCP, or Azure.
Okay.
Right? Yeah. Don't say Heroku. So every other child is using Heroku, I can say.
So it's like it's a deployment.
Yeah. So don't even try to take the name.
Okay.
Because people will understand that what is your label in that case. So extended system scalability. So basically, like if you're going to attach this system, which is trying to project like a diet, which is trying to give a dietary recommendation, right? So how you can use the same system, same dietary system to how you can integrate the same thing with the other system. So maybe you can say that in that case, if I will be you, so I can give an answer like I can integrate this system with the healthcare system, and where.
तुम लोग बकवास करते हो यार. He's still one of the best death bowlers. He was. अभी the scenario has changed.
Okay, great. Removed one user. Okay, so here basically extended system. So extended system scalability, right? So in that case, people will expect your vision. Basically, people will look for your sort of, I can say, what kind of visibility that you have, how you understand a systems. Basically, not only this system which people have given you to design, other systems basically. So if I will be you, so in that case I would have given an answer that okay, so extended system wise, so we can integrate the same dietary components with other systems, because we are already capturing a health record. We are already capturing their height, weight, health, age, each and everything, their family disease or whatever historical disorder that they have, or maybe like a hierarchical disorder that they have. So we are capturing each and everything. Based on that, we are trying to predict the diets. We are trying to give us suggestions. We can use a same thing to forecast and predict a diseases that user is going to get basically into a future. And based on that disease, so maybe we can recommend them a precaution, or maybe we can recommend them a medicine, so that after some time, so they will not be able to get that kind of a disease which we have predicted or forecasted. Yeah, so that is called as a extended, I can say, a system scalability. So where you try to integrate your system, your data set with a n number of systems. Now integration analysis, same thing. I'll say system rollout and commercialization. So yeah, how you're going to make it as a commercialization, commercialize it. What will be your selling point basically? So if I'll give you the system, so on what basis you will be able to sell it? You're not supposed to say that, okay, fine, I have a mobile application which will give you diet recommendation, so please take it. No, there should be some selling point that you should create. There should be some value that you should create. So you're supposed to think about that, and you're supposed to mention that over there.
How to do that one in selling point?
Your brain, right? Think about
the branding.
Like the ads which we got on Facebooks, or
So basically a selling point people will look for. So in an interview, so they will not look for like you will go and you will sell it directly. No, they will say that, okay, fine. So what is your approach? If you have built some product, right? Why you have built some product? If you are building this dietary recommendation system, why? Basically, just because other person is going to get some like a regular 3 times diet recommendation that, okay, fine, you should eat that one. No. Selling point could be, so basically it is not only going to give you a dietary recommendation. Apart from that, so it is going to give you suggestions that, okay, fine, so if you're not eating well, if this is the diet, then this could happen to you. And if you have some existing disease, so in that case, basically it is going to give you a recommendation about the doctors as well as for medicine as well as for hospitals, right? So that will be a selling point. Think about that. Try to add 4 or 5 more points. I think I have already told you enough points, right?
Yes.
You can watch the recordings.
Step 6 is same as 7 to 9 integration and analysis.
Yeah, it's almost same. Yeah.
So when they said mobile application system implementation, is that a deployment or data collection?
Both. You are going to collect some data. User is not going to send your data in their email, right? You are supposed to create some interface, right? And through that interface, user will try to insert some data. Agree?
Yeah.
And then again, whenever you are going to show some report, so you are going to showcase some report in some mobile devices, right? Or some application. So in both way, it is going to work in the data collection as well as in
how we will deploy our machine learning models into mobile things.
Figure it out. I think we have already, okay, in your class, we are not in deployment, right? Okay, figure it out. How we can deploy it.
Is it a Flutter kind of application?
Figure it out. In your panel batches, I think we have already done deployment for you. Try to explore it. Or else try to search for my videos on YouTube.
Yeah, I have a little knowledge in deployment, like converting to the web application using Flask and deploying into various sources, AWS, Pivotal, everything.
Fine.
That is web applications. What about mobile applications? I'm asking.
So in mobile application also you can call a server, right? You can call an API.
What kind of?
And if you're trying to, sorry?
Is there any specific thing?
No, simple web API. So web API you can call anywhere, whether it's some mobile devices, whether it's any other things, basically. So web API you can call anywhere, right? There is no restriction with the web API. It's not like you will be able to call just with the web, just with the desktop.
Yeah.
So Dhanshu, here, I mean, there can be 2 things, like native web app, native mobile app, or the
native mobile app. So in that case, people will again raise a question that if you are trying to execute into a native, so for sure mobile will not be able to execute your pickle file or SAV file or basically CKPT file or .pv file or .h5 file, right?
Yeah.
Then what is the solution?
So here we can assume that we are opening browser in mobile.
No, there is a way. There is a way to deploy even those models, and that's the reason. So as he is not having any idea about those things, right? So unnecessarily, you're not supposed to get stuck when you don't know anything. Because if there will be a person like me, you will tell me that, okay, fine. So natively, I'm going to apply a mobile, deploy these things into a mobile application. My next question will be how?
Yeah.
But if you're going to say that, okay, fine. So we can expose this as a web API. I'll not ask any question. I'll understand that.
Yeah,
right?
Yeah.
So based on your existing knowledge, you should answer it so that you will not get another question.
Yeah.
So try to avoid those things at least. Fine? Okay, everyone. So thank you so much for joining the class. See you tomorrow again, same time, 2 o'clock. Yeah, thanks. Bye.
Hello, Sudhanshu.